Hello, it's Professor Bodrero again. Now that we've got a handle on the framework for hypothesis testing, we're going to get into the nitty-gritty of doing hypothesis testing about a population proportion. So our objectives here today are to know and verify the requirements for a hypothesis test of a proportion, and then perform and interpret a hypothesis test for a population proportion. So first thing we need to do is make sure that we're using the right tool on the right problem, and so we need to do a requirement check. And as we've seen, we need to have a random sample so that it is likely to be representative of the whole population. We also, since we're dealing with a population proportion, we need to be a binomial. And once again, the requirements to be a binomial are fixed number of trials, which we call n. Okay. You must have two outcomes, which we refer to as success and failure. Okay, and they just mean category 1 and category 2, and therefore and finally our trials must be independent so that the probability of success is a constant across all trials, little p. Okay. Then to make sure that our sample size is large enough, we remember that we need, for the bell curve to work, we need n times p to be greater than or equal to 5 and n times q to be greater than or equal to 5. So we need both of those. So once those three things are good, we are okay to start with our hypothesis test of a population proportion on a binomial. So one of the things that my wife and I recommend is doing recycling. So a survey done a year ago showed that 25% of the population participated in recycling programs. In a recent poll, a random sample of 110 people showed that 36 participated in recycling programs. Does the data indicate that the proportion of the population who participate in recycling programs is greater than it was 1 year ago? Use a 5% level of significance. Let's go through this all together. First off, did we have a random sample? The answer is yes, and we will be looking for this on homework and tests. So make sure that you do show us that you are checking these requirements. Is it a binomial? Well, we had a fixed number of trials because we had 110 people, so that's n, but that's not enough to convince us that it's a binomial. We need to make sure that there's two outcomes so we can group them into success and failure. So we're going to call a success, by the wording of the problem, is that the person recycles, and then a failure is person does not recycle. Okay. And if one person recycles, that doesn't say anything about whether their neighbor recycles or not. So our trials are independent, and therefore the probability of success will be a constant number, which we've referred to as little p. Okay. And speaking of little p, the survey done a year ago was that 25% of the population did recycle, and since success is recycling, we're going to say that little p is 25%. That's our default. Okay. And we need to double check and see if n times p is greater than or equal to 5. So we'll do n, which was 110, times p, which is 0.25. And that's going to give us, let's double check that, 27.5, which is way bigger than 5. And then q, it's going to be 110 times 0.75, the complement of the 25%, which is equal to, what's that going to be, 82.5, right? 82.5, which is also way bigger than 5. So going back to our concept map, you'll see that we decided we're going to do a hypothesis test on the population proportion. We've done our requirements, and we'll talk about so binomial random sample, and then to be able to use the normal approximation of the binomial, we need NP and NQ to be greater than or equal to 5 on our hypothesis test. Okay. We'll get to this one prop Z test in a minute. But let's come back here. Oops, I bumped the paper. So X was the number of successes, and in our sample we had 36 people who did recycle, so that's our number of successes. P hat is the sample proportion of success, so little p hat is 36 over 110, which turns out to be 0.327 to 3 decimal places. Okay. And alpha, our risk of a type 1 error, is 5%, so we will write 0.05. Now, it sometimes helps to go back and reread the problem. So, in a recent poll, a random sample of 110 people showed that 36 participate in recycling programs. Does the data indicate that the proportion of the population who participate in recycling programs is greater than it was 1 year ago? Ooh, that 1 year ago was 25%. So the claim that we're putting on trial is if the population proportion now that recycles is greater than 25%. So our null hypothesis would be that the population proportion is 25%, or if you want to get really technical, that the population proportion is less than or equal to 25%. But I'm more than happy with this. And also remember that in addition to HA, we can also use the notation H sub 1. All right, looking at our alternate hypothesis, the claim we're putting on trial is a greater than, and greater than is to the right on a number line. So this is going to be a right-tailed test. And if I want a 5% area in the right tail on the Z distribution, I'm going to need 5% to the right would give me 95% to the left. And once again, we're going to go to our good buddy Z table and to get 95% to the left, so we'd have 5% to the right, we need 1.645, smack dab between those two guys. So our critical value is going to be Z sub C equals 1.645. So that would be right here, and we'll label him. So we've now set up our jury and we're ready to go. If our evidence lands us here, we will come back with a verdict of guilty because that's beyond reasonable doubt. If we come back with a number here, then we didn't have enough evidence for a guilty verdict. So now it's actually time to listen to the evidence and find the test statistic. To do that, we find it by doing this formula, p hat minus p, all divided by the square root of pq over n. So in this case, that would be 0.327 minus 0.25 divided by the square root of 0.25 times 0.75 over 110, all inside the square root. And if we do that on our calculator here, using parentheses where needed, okay, I'm going to use the order of operations, so 0.25 times 0.75, and then divide that by 110, close the order of operations, and then close the square root, and we should get, whoops, what did I do? Oh, one extra parenthesis there. I should get a test statistic of 1.87 to 2 decimal places. So 1.87 would be right here on the picture. So notice we'll label him, but we won't put a C on him because he's not a critical value. He's the test statistic. And since our test statistic landed in this critical region, beyond reasonable doubt, we're going to reject H naught. Therefore, we have enough evidence to conclude that the proportion of people who recycle now is greater than 25%. Okay. And we'll pick up there with the next video.